What if I told you that understanding the universe is a lot like understanding a cat? Imagine the curiosity that drives a cat to explore every nook and cranny of its environment. That same curiosity fuels scientists as they delve into the mysteries of the cosmos. Both are full of mysteries, bursts of energy, and a healthy dose of chaos. A cat's unpredictable antics mirror the unpredictable nature of scientific discovery. Just when you think you have it all figured out, something unexpected happens. But sometimes chaos leads to incredible discoveries. A cat might stumble upon a hidden toy, just as a scientist might stumble upon a groundbreaking theory or an unexpected result in an experiment. Just like a cat batting at a laser pointer, scientists use tools to unlock the secrets of the cosmos. The laser pointer captivates the cat's attention, guiding it to new discoveries, much like how scientific instruments guide researchers to new insights. One of those tools is called a penning trap, and it's a lot cooler than a ball of yarn. This device allows scientists to trap and study charged particles with incredible precision, opening up new avenues of research and understanding. So, the next time you see a cat playing, remember that its curiosity is not so different from the curiosity that drives scientific discovery. Imagine a tiny arena smaller than a whisker where particles are the main event. This is a penning trap, a special device that traps charged particles like electrons or ions using electric and magnetic fields. Think of it as a miniature electric fence for tiny bits of matter, keeping them contained and ready for study. The penning trap has three main parts, two end cap electrodes shaped like saucers. These saucer-like electrodes are positioned at either end of the trap, creating a symmetrical setup that is crucial for its function. Imagine these electrodes as the boundaries of a playground where particles can move around freely, but are still confined within certain limits. And then there's the ring electrode, which acts like a collar. This ring electrode sits in the middle, encircling the particles and providing an additional layer of confinement. Just as a collar keeps a cat within a certain range, the ring electrode ensures that the particles don't stray too far from the center. These components work together to create an electric field that traps the particles, much like a cat might be contained by the walls of a room. The electric field is carefully balanced to ensure that the particles remain in a stable position, unable to escape the confines of the trap. It's a delicate balance, much like keeping a cat entertained within a small space. But here's the twist. A strong magnetic field runs through the trap, causing the particles to spiral in circles. This magnetic field adds another layer of complexity, making the particles move in a helical path. It's like adding a new dimension to their movement, making the trap even more effective at confining them. Picture a cat chasing its tail, but on a much smaller and faster scale. The particles move in tight spirals, constantly changing direction, but never able to break free from the magnetic field. It's a mesmerizing dance of physics, much like watching a cat endlessly spin in circles, captivated by its own tail. Now, the fun begins. Scientists use these trapped particles to study their properties with incredible precision. By observing how the particles move and interact within the trap, researchers can learn about their mass, charge, and other characteristics. It's like watching a cat stalk a toy mouse. Their every movement reveals information about their instincts and abilities. Penning traps help us understand the universe in profound ways. They are essential for creating extremely precise atomic clocks, which are crucial for GPS navigation and other technologies. They're also used in cutting-edge research on antimatter, the mysterious counterpart to ordinary matter. Did you know that the Schrödinger's cat thought experiment, a famous paradox in quantum mechanics, involves a cat? This thought experiment was devised by Erwin Schrödinger in 1935 to illustrate the concept of superposition, where a cat can be simultaneously alive and dead, depending on an earlier random event. It's a fascinating way to think about the strange and counterintuitive nature of quantum mechanics. While not directly related to penning traps, it highlights the playful and sometimes mind-bending nature of scientific exploration. Penning traps, used to confine charged particles using magnetic and electric fields, also delve into the mysteries of the quantum world. They allow scientists to study particles with incredible precision, revealing the hidden behaviors and properties of matter. Just like our feline friends, the universe is full of surprises, waiting for us to unravel its secrets, one particle at a time. Whether it's through thought experiments like Schrödinger's cat or advanced tools like penning traps, the journey of discovery is endless and filled with wonder. So, keep your curiosity alive and never stop exploring the cosmos.